In this problem, we'll solve a system of equations using the elimination method. We'll solve the system of equations negative 4x minus 9y equals 4 and 6x plus 3y equals 1. To use the elimination method, we need to find a variable, x or y, so that the coefficient in one equation is the opposite of the coefficient in the other. The coefficients of x are negative 4 and 6. The coefficients of y are negative 9 and 3. At this point, neither of them are opposites. However, I notice that 3, if I multiplied it by 3, I would have 9, which is the opposite of negative 9. So I am going to multiply this second equation by 3. I'm going to multiply 6x by 3, 3y by 3, and 1 by 3. And this equation I'm going to leave alone because I already have minus 9y in it. Now when I add these two equations, I have negative 4x plus 18x is 14x, negative 9y plus 9y is 0, and 4 plus 3 is 7. So I have x equals 7/14, dividing both sides by 14, or x equals 1/2. Now I know the x value, I need to find the y value. I want to take 1/2 and substitute it for x in either of these equations and find y. I'm going to substitute it for x in the second equation, and I'm going to choose that because the first one has more negative signs and probably a little more room for error. So I'll start with 6x plus 3y equals 1. If x is 1/2, I get 6 times 1/2 plus 3y equals 1. 6 times 1/2 is 3. 3 plus 3y equals 1. Subtracting 3 from both sides, I have 3y equals negative 2. Dividing both sides by 3, I have y equals negative 2/3. Now I have an x value and I have a y value. In order to tell me for sure if these are going to be a solution, I need to substitute 1/2 for x and negative 2/3 for y in both of these equations to see if it makes them both true. And it does. So I can state, and since I have a lot of work there, I'm going to state it real clearly so the answer doesn't get lost, and state it as an ordered pair. The x value was 1/2, so it gets written first because it comes first alphabetically. The y value was negative 2/3. And that's the solution of the system.